Hi, I'm Yuxiao, a PhD student at Carnegie Mellon University. Welcome to our paper, RISE, Recursive IntroSpEction, Teaching Foundation Model Agents How to Self-Improve. This is a joint work with Tianjun Zhang at UC Berkeley, Garg at Multi-On, and Aviral Kumar at Carnegie Mellon University. We noticed that current large language models, even strong ones, often struggle to improve their responses over multiple attempts. As shown in prior work, even change to better refinement prompt, self-correction consistently results in a decrease in performance. Therefore, our goal in this work is to develop a method to teach language models how to self-improve effectively. To give an intuitive sense of what those mistakes look like, here are some examples. And after fine-tuning with RISE, the model is able to figure out the error and maintain the correct steps in previous response and correct the mistakes. To achieve self-improvement, several approaches have been explored. Prompting techniques like chain of thoughts and self-refine have been proposed, but they often need model-specific prompts and external feedback to maintain improvement over turns. People also try to fine-tune on domain-specific Oracle solutions, or use multimodal systems like Glory with different models for generation, criticism, and refinement. Our new method, RISE, takes a different approach. As a single model solution, RISE doesn't need model-specific prompting and learns from both optimal and suboptimal data. Most importantly, it improves consistently with more attempts without external feedback. In addition, it can generalize to other domains, making it a versatile tool for various problems. Now we will introduce RISE. We first convert single-term problems into a multi-term Markov decision process, where the state is the user's prompt or the environment's feedback. The action is the entire response generated by language models given the complete conversation history, which includes all previous states and actions. The reward is based on the correctness of only the answer in the language model's response. We then collect data by unrolling the current model at most k-1 times in the kth iteration to collect on-policy mistakes, and construct an improved version of the response by either sample multiple responses from the current model and use the best one, which we call self-distribution, or create a more capable model, which we call distribution. We can repeat this process iteratively collect the data with more unroll steps. With the aforementioned data construction schemas, we then use reward-weighted regression for fine-tuning the model. In this process, ST, YT, and RT represent the state, action, and reward at step t, respectively. We also introduce a temperature parameter tau to further expand or narrow the difference between good and bad actions. During inference, RISE can be run in two modes. If a reward function is available, the model samples a new response condition on the past context, and we terminate rollout as soon as the current response is judged to be correct. If there is no reward function, then we follow a similar schema to the data collection stage, but with two key differences. First, we don't generate improved response, but only roll out the current model. Second, we don't have Oracle environmental feedback. Instead, we simulate a scenario by always telling the agent that its answer is wrong. This forces the model to generate multiple responses based on previous mistakes sequentially. We then apply majority voting on the candidate outputs from different turns to determine the final response. Before we dive into the experimental results, let's address a fundamental question. Why is self-improvement over turns even possible? We identify that the key reason is an enhanced model expressivity. By converting the single-turn question-answer framework to a multi-turn Markov decision process, the model is now actually learning a sequence of conditionals, which can represent more flexible distributions, making it easier to learn the target distribution. In the left figure, we measure the overall probability of the true answer given the prompt for two models. Classic one trained with prompt and one-turn oracle solution, and the model trained with RISE. For the model trained with RISE, we marginalized all intermediate states. It clearly demonstrates that as training progresses, RISE model has smaller loss and a higher corresponding probability, indicating that the model becomes more confident and more likely to output the correct answer as the response. To further corroborate this finding, we conducted an additional experiment on the right. Basically, we collected the problems that cannot be solved by sample 5K responses in the first turn, where K is ranged from 1 to 6. However, by running RISE, there are 10 to 40% of problems can be solved within 5 steps of sequential sampling. In other words, this shows that training with RISE allows the model to solve problems that even larger sampling budgets at the first turn cannot solve. Now, let's shift to our results. On Common Mathematical Reasoning Benchmark, GSM-AK, RISE improves the performance of a fine-tuned Llama 2 7 billion model by 17.7% over the course of 5-turn introspection if you use a capable model to generate an improved response for fine-tuning. Whereas the parallel sampling with the same generation budget at the first turn only improves the model by 13.7%. This demonstrates that after running RISE, the model can utilize information from previous terms and achieve self-improvement. RISE can also be deployed on other models. It can improve Mistral 7 billion by 23.9% over 5-turn introspection, while parallel sampling in the first turn only improved 15.3%. Similar trends hold on math, another benchmark, where RISE improves the Llama 2 7 billion model by 4.6% and the Mistral 7 billion model by 11.1% over 5 turns, with no oracle guidance. Look for other methods like direct fine-tune model with single-turn QA demo with only optimal solution or both optimal and suboptimal solutions, or prior work for self-improvement like self-refine, glory. The gains are much more smaller and often negative. Even when so-taught lemmas at the 7 billion scale are used, this demonstrating that the effectiveness and the generalizability of our method. We also compared the performance of RISE with entirely self-generated data and supervision during data collection stage. Basically, we only use the model itself to generate improved response for fine-tuning. After one iteration directly on top of more capable models, Mistral 7 billion and Llama 3 8 billion on GSM-AK, we find that this variant also improves the 5-turn performance of the base model compared to the first turn. Finally, we're also interested in the robustness of the strategy induced by RISE on new unseen prompts. Specifically, we evaluate model fine-tuned on math environment on GSM-AK testset, model fine-tuned on GSM-AK environment on math testset, and the model fine-tuned on a mixture of GSM-AK and math on the SWAMP dataset. Generally, we observe that the model trained on one dataset is still able to improve the model's performance on another dataset over the course of sequential 5 turns. In the paper, we also studied some other interesting properties of the method, including does the performance of RISE improve with iterative training? What data composition and objective are crucial for RISE? How the correctness of model's response change from turn to turn, and how data generated with RISE on weak model improve the performance of a stronger model. If you want to learn more about details of RISE and are interested in these questions, definitely check out our paper, and project webpage. Finally, I want to emphasize the key takeaway for this paper is we can get language models to self-improve their own mistakes if we train for it properly. This is a capability that even strong proprietary models don't have, and we show it's possible to get this via RISE. Once again, for more details, definitely check out our project webpage with the link or scan the QR code and reach out to us if you have any question. Thank you.